Welcome to lab number 5, build a simple network. So in this lab, we are going to build a larger network. We are going to connect multiple switches, and we're going to connect clients or laptops to those switches, and we're going to make everybody communicate together. You can think of this as building a network to support a large office building. Let's say it has 2 floors, maybe 20 employees per floor. So we need switches to connect all of those employees together. We need to connect them to printers. We need to do a bunch of different stuff to make sure that that office can function correctly. So there's some hardware that we're going to need. Again, I'm going to do this in Packet Tracer. It's all going to be virtual. You'll be using physical equipment in the classroom, but everything's going to work the same. We should start off by booting these switches. So connect to the switch, issue these commands to reset everything, and then once everything is reset, we're going to cable it. I'm going to go ahead and do this in Packet Tracer. So I'm going to add a 2960 switch here. I'm going to change the label to S1. Add another switch. This one is going to be S2. I'll click on this switch just to show if you click on the wrong spot, the world doesn't end. I'm going to come to config. Device is still booting, that's fine. So display name, I'm going to call the display S2. I just want to make it match what this diagram shows. Now if I was doing this in the classroom, I would want to connect through PuTTY and run the commands. En show flash. There's no vlan.dat file, but I'll run the command anyway just for fun. Delete vlan.dat is what you should do. Hit enter. Enter to confirm. There's no file, but that's okay. Doesn't hurt anything just to try to delete it. Then erase. Start. Hit the tab key so you don't have to type that whole thing out. Erase start config. Just straight enter to confirm. Don't type yes. And then reload and confirm that. So it's going, that one's rebooting, so I'm just going to close switch 1. Let's just do it on switch 2. Press return to get started. Come to the command line, tab. En show flash vlan.dat, even though it's not there, I know it's not there, I'm just going through it. Erase, startup, config, enter, enter to confirm, reload. We really want to confirm it. So now that's reloading. So you can see that didn't take very long to do. It's going to take you a bit longer if you have to connect with PuTTY and make sure you find your right COM port in the device manager and connect things physically, but this should be a fairly fast process. Okay, so I've reset my switches, I've labeled them. Now I'm going to go through and cable. So I'm going to use straight through cables, Ethernet cables, to connect computers to the switches. And a straight through cable, I can use a crossover or straight through from switch to switch. Honestly, it doesn't actually matter. Technically, it would be better to use a crossover cable to go from the same type of device, but for simplicity's sake, we'll just use copper straight through. So this diagram, let's make sure we interpret this correctly, F01. So that's fast Ethernet port number 1 on my switch. So I'm going to click on switch 1, choose fast Ethernet 0/1. And connect it to fast Ethernet 0/1 on switch number 2. Now some people, you might wonder, as I did the first time I was doing this type of configuration, why does it say 0/1? These are all 0/something. What is that 0 for? Well, the 0 just refers to the network interface card. Here, all these interfaces, I'm just going to hover over, you can see they're all 0/something. It just means there's one big, really powerful network interface card on this switch. If there were multiple cards on this switch, I would have other interfaces that said something like fast Ethernet 1/25 or something like that. We don't have to worry too much about that as long as we know how these are labeled on this particular switch. So I've got that one cable. Okay, I need 4 computers, so I'm going to click End Device. I just want the one at the very left, this generic PC. I need 1, 2, 3, 4. You can drag these around. Okay, I'm going to change the labels on these devices right now. I'm going to change PC 0 to computer A. Close that. You might be tempted. You can put character returns in here and say IP address. Unfortunately, the text does not actually wrap. I'm going to delete that IP address. If you wanted to label things on your workspace, we can use this text box, this note feature. So I'll say 192.168.0.10.55. I can place that. Now to move it, I have to make sure I have the selection icon pressed. So I'm in selection mode. And I can drag that around where I want to. They're not going to hang together, that's okay. Limitation of packet tracer, but we'll be fine. So computer B, I'll have be more accurate with my clicking. Computer C, and last but not least, computer D. So I'm going to just copy and paste that stuff all around. Change the IP addresses. The only thing I have to modify for these computers, son of a gun, if I could click in the right spot, is that last part of the IP address, the 4th octet here. So question for you, are all of these IP addresses on the same network? How would you know? I'm actually going to put that IP address above so our cables won't get in the way. So are they on the same subnet? How do we determine that? Well, let's look at the subnet mask first. We've got the first 3 octets filled up, basically, meaning that the network is defined by the first 3 octets of our IP address. So everything in the 192.168.0, any IP address that starts with those numbers is going to be on the same network as long as everything's wired and connected properly. So these should all be on the same network. So I've got my computers labeled. Let's connect everything. So I'm going to connect computer A, Ethernet 0 to the diagram tells me port 6. So let's do that. I'm going to connect computer B, its Ethernet port, to port 18. It's looking good. Let's go to computer C. I'm going to connect it to interface 10, port 10. I'll use port and interface interchangeably. That's good. We've got amber lights right now. Those should turn green. Computer D, connect the Ethernet port to port 12 according to my diagram. That's good. We've got some green lights on switch 1. Switch 2 should turn green. Did that one next. There, it's green. Computer C and computer D, those lights should turn green soon as well. For this example, because I'm using packet tracer and have godlike mode to configure these switches, I'm not going to connect the serial cables. However, if you're using the physical switches, remember the initial configuration always has to be done using that console port using a serial cable. Okay, this is good. We've got green lights across the board. Yay, I'm happy. Green blinky lights, typically that's a good sign. All right, so I'm done with that section, so I'm going to come to the switch configuration. All right, switch 1. Let's do this. So I want to make changes, so I'm going to go into privileged exec mode, and to do that I type en or enable. I want to make some changes, so I'm going to say conf t, or you could type out configure terminal. First thing I want to do is change my host name to S1. So this should match the label I've put on the workspace. The label on the workspace doesn't actually change the switch's configuration. This label is just for the graphical display on my network workspace. Changing the host name on my switch actually changes the switch's configuration. Just a quick note about that. All right, so let's configure our console port, do some basic configuration. Line com 0, that will tell me I'm going to protect that console port. Logging sy tab, use that tab complete. It's your friend. Hit enter. Password class, login, exit. And bam. So we've password protected that console port. We've also disabled annoying messages popping up and distracting us. So I'm going to run enable secret Cisco. So if anytime someone runs that enable command, it's going to prompt them for that password. Banner MOTD, that's message of the day. No unauthor, I always misspell that. Access, end it with another pound symbol. Exit. So switch 1 is good to go. Let's take, let's go ahead and save this. So how do we do that? We save with the copy command. So we're going to copy running, I'm going to use the tab complete, running config, use the tab complete, just type star tab, it'll give you startup config. Hit enter, it tells me destination file name, startup-config question mark. Again, we're not going to type yes or y, not going to work. I'm going to hit enter. Built it, okay. So now even if I reboot this switch, my host name, passwords, all that stuff, it's going to come back up correctly. Let's see, I can, if I want to check my configuration, I can type show run. Everything's looking good. I've got my enable secret, and you can see it's hashed. So nobody knows what my secret is there. It's looking good. I've got my message of the day. I've got my console password. You can see there it is in clear text. Someone looking over my shoulder could discover what that password is. So we don't want people shoulder surfing, a very basic kind of attack. But yeah, looks good. So show run is good for checking everything. And I can run show IP int brief. I can see what's connected. I'm going to make this a little bit wider so I can see it all on one screen. So I can see I've got something attached to interface 1, 6, and 10. Looks good. The output from here just had nothing assigned to number 10, to interface 10. That's fine. Yours might look slightly different. That's okay. It just depends how many group members you have, how many computers you're actually connecting. So don't worry about that. If you don't have anything connected to 10 and it's still down, that's fine because nothing's connected. If you do have something connected to interface 10 and it shows down, well, that's a problem. So there are three states that we should be concerned about. So up means that the interface is turned on and something is plugged in and there's an active connection. Something is down if that interface is turned on, meaning it's willing to accept connections, but there's no connection. So that means either a cable is unplugged on your end or on the receiving end. Something's not fully connected. Or an interface can be administratively down. That means you've turned it off, you've disabled it, and it doesn't matter if you plug something in, that's been administratively turned off. So a connection, the switch will not even try to connect. So here we have VLAN 1 is administratively down. We will talk about VLANs later. We don't have to worry about that today. Okay, so I'm going to scroll back up. Now I need to make these changes on switch 2 as well. Even though the switches, we have to do it to both switches. The example here is use a switch 1, but everything basically works for switch 2. We just change S1 to S2. So enable config T, hostname S2 this time. So that should match the label on our workspace. Everything's looking good. Make sure we're configuring the right device. So line con 0, logging sy tab, looks good. Password class, exit, enable secret Cisco, banner MOTD, no unauthorized access. Yeah, misspelled it. I thought I got it. I was close. Unauthorized access. There we go. And we're good there. So copy, running config, startup config, enter. Just use enter again to save that. I can say show run. Everything looks good. Show IP int brief. That'll show me all my interfaces, how they are doing. Again, depending on what you have plugged in, some of these should be up, many should be down. Everything looks correct here. All right, good. So here's a question for you. Should computer A be able to ping computer B right now? You tell me. Let's try it. Just guess. Should computer A be able to ping computer B? Ping 192.168.0.20. When I hit enter, what's going to happen? Think about it. Pause the video if you need to think some more. Otherwise, I'm going to hit the enter key in 3, 2, 1. Pinging that IP address with 32 bytes of data. Request timed out. So that's not good, right? Timing out is generally a bad thing. It's still going to time out. Yeah, this isn't going to work. In the Windows world, it tries 4 times and then it just gives up, whether it was successful or not. So why wouldn't this work? We've got all these green lights everywhere, right? Well, we haven't set any of the IP addresses. Okay, so obviously we need to do that. I put a label down here to say what the IP address should be, but we never actually configured the IP addresses. So let's go ahead and do that. Computer A, I'm going to, on the desktop tab, click IP configuration, static 192.168.0.10, hit tab. I am happy with that subnet mask. It matches what it's supposed to be, so I'm going to close that. Computer B, I'm going to click the desktop tab, IP configuration 192.168.0.20 tab. Subnet mask looks good. Close that. Computer C, desktop tab, IP configuration 192.168.0.30. Hit tab, it fills in the correct subnet mask. So helpful. Desktop IP configuration, 192.168.0.40. Make sure to use your 10 key skills. Hopefully you know how to use that 10 key. Type all this stuff in quickly. Okay, so now all of these have IP addresses. Now, should computer A be able to ping, let's say computer C connected to the same switch? How about that? Should I be able to, I'm going to use the up arrow key. Should this ping work? Computer A pinging computer C. Both computers connected to the same switch. Both computers on the same subnetwork. Let's try it. Successful reply. Yay, that's good. We like that. Now, should computer A be able to ping computer B? So computer A and computer B are connected to different switches, but those switches are connected with the cable. So is that going to work? Let's do an experiment. Ping 192.168.0.20. What do you think is going to happen when I hit enter? Is it going to succeed or fail? In 3, 2, 1, we're going to find out. It worked. So essentially, these switches pass information across to each other. We kind of combine these switches into one big switch. So we can connect a whole bunch of computers here. So that's good. A was able to ping computer B. Remember, if computer B was running a real Windows operating system, and all we did was change the IP address, that ping would fail. And why would that fail? Likely because of the firewall that is enabled by default. So if these A, B, C, and D, if these are Windows computers, you would also have to temporarily disable the Windows firewall for that to work. Okay, so that's good. Connectivity, yeah, my connectivity was good. I was happy with it. Everything seemed to work. In your groups, everybody should try to ping everybody else. All those pings should be successful. If they're not successful for some reason, you have to start troubleshooting. Make sure that your IP addresses are correct. So if you need to, come to the command prompt, run ipconfig, check for the IP address and subnet mask. That's number 1. Make sure the cables are plugged in. You should see the green blinky lights. If you see something that is not a green blinky light, you might have a bad cable. The cable might not be plugged in all the way. Things happen. It might just be a bad cable. If you have a bad cable, just throw it away, get a new one. If you're troubleshooting, you can run show IP into brief, and that will tell you if the switch thinks something is connected or if something's administratively down. And double check that your firewalls are disabled. If computer A can ping computer B, but computer B cannot ping computer A, that's almost always a firewall issue. Okay, so there's some things that we did in here that you should be able to know. When computer A pings computer B, you should be able to mentally trace the path of that signal, where it went. So it's going to go over that Ethernet cable to switch 1, through the cable to switch 2, then over that cable to computer B and back to get the response. Now in this example, the pings all went over these Ethernet cables. I will go ahead and I will connect a console cable to switch 1. Let's do this test. So I've got 2 cables connecting computer A to switch 1. So if I come here and I run this ping command, is that going over the Ethernet cable or the console cable? Think about that for a second. I'll let you think. I'm also going to open up the terminal. Again, this is basically equivalent to PuTTY in the Windows world. So right now, from computer A, you can see up here in the top left, this is from computer A, I am accessing this switch. So what cable is carrying the commands that I'm typing right now? What cable is this going over? Unrecognized command. Yes, that is not a recognized command. Config T. Well, that is actually going over the console cable. The console cable is carrying these commands to the switch. If I open up the command prompt and I do a ping, that is not going over the console cable. Let's see if I can... I wish those did not overlap so completely. Okay, so that's selected. I'm going to try pinging, and then I'm going to delete that console cable, and you can see that my ping kept happening. I tried to do it fast. I can still ping. Whether or not that console cable is plugged in, it's still going to work. Okay, so again, when you're using ping, that's going to go over your Ethernet cable from a PC. But if you're using Minicom or PuTTY, that will go over the serial cable. So it's good to just be aware what all these cables are doing that are plugged into the computer. So we've created a simple network that spans multiple switches, and we verified connectivity. We also used the commands show IP int brief. And we talked about what it means, what that status means. If the status of an interface is up, down, or administratively down, this command is extremely useful for troubleshooting. Okay. So what I want as far as a submission when we do this in class is just a successful ping, pinging the other machines in your group. That's good. And that tells me that everything was cabled correctly. It tells me that all the IP addresses were set correctly, firewalls were configured correctly, everything. So when you're done with the lab, reset the switch configurations. So I'm going to come here. So I'm going to say show flash, delete vlan.dat. Yeah, sure. Yeah, it's not there, but I'm going to delete it anyway. Erase startup config. It's going to erase all the configuration files. Yep, sounds good. Reload. Confirm. So I'm going to close this. At this point, you can disconnect your console cable. So all these are red because the switch is rebooting. I'm going to come here to S2, enable password is Cisco, show flash, no vlan.dat, but I'm just going to do it. It's important if there is one there. Erase, start, tab, enter, enter, reload, enter, enter. So that's rebooting. Looks like S1 is rebooted, it's coming up. So command line. Okay, we've got a flat switch again. Got a message, fast Ethernet 1, change state to up. Let's wait a second for S2 to wake up. It'll take maybe another 10 seconds or so for all these lights to turn green. So I'm going to bring up computer A while that does that. Let's try our ping again. Is this going to work? What do you think? I just reset the switch configurations. Will computer A still be able to ping computer B? That is the question. These are basically out-of-the-box, factory-fresh switches now, S1 and S2. Let's try It worked. Okay. So that's expected. One thing that we should note is some of the configuration changes that we made to these switches were just to secure the device. Pinging and everything, out of the box, switches can do quite a bit for basic networking scenarios, but there is a compelling reason to make the configuration changes, to set passwords, to change the host name, especially as our networks start to grow. So that's it. After your switches are reset, make sure to reset your network connection to obtain an IP address automatically. Turn your firewall back on. Just make sure your network is working properly. And that's it for this lab.